Assalamu alaikum guys, welcome back. Today we are going to discuss about stationary points. We also call them what? Turning points. This is the points where the curve turns. So we have three types of stationary points. We have maximum point, we have minimum point, and we have point of inflection for your information. So today we are going to see how to calculate the values of the point of the stationary point or the turning point, as well as how to determine the nature of the turning point. Okay, determine the nature, whether it's when we are saying the nature, it means whether it is maximum or minimum. Okay, whether it's maximum or minimum. To start with, let us see the first example. Example 1, you are told find the stationary point. Find the stationary point on the curve. On the curve y is equal to x cubic minus 9 out of 2x squared plus 6x minus 9 plus 6x minus 9. So let's see this one. So this is the equation of the curve. Don't forget, this is 9, yeah? So the first thing you're going to do is, when you want to know, actually you're told find the stationary points. When you want to get the values of the stationary points, you are going to differentiate this equation of the curve given. Okay? Then this is what we'll be doing. You're going to say solution. So you're going to say dy over dx. But before I say that, let me write the equation here. I have this equation. Y is equal to x cubic minus 9 out of 2x squared plus 6x minus 9. Remember, in our previous classes we have learned differentiation concepts. So now our dy over dx will be, this one differentiated, it will be 3x squared minus 9x plus 6. Okay? Minus 9x plus 6. So remember, we say that at the turning point, comma, dy all over dx is equal to 0. At the turning point, the gradient of the curve is always 0. So we are going to say, we will equate this one to 0. So we are going to say 3x squared minus 9x plus 6 is equal to 0. Remember, this will take you to quadratic. You can use product and sum method by saying our product will be, product is a times c, that is 18, positive 18, and our sum will be negative 9. So we need to get two numbers whose product will give us positive 18 and their summation will give us what? Negative 9. So what you know is 3 times 6 will give us what? 18, okay? So remember, if we take these two, let's see what's going to happen. Or we have also 2 times 9, okay? This will also give us 18. So these are the two ways we're going to take. Remember, when we have negative on the sum side, in form 3 and form 2, we have discussed this one at the end. When we have negative on the sum side and positive on the product side, remember the two numbers we are going to take are both negative. So this negative 3, negative 2, negative 9. So negative 3 times negative 6 is positive 8. Is okay. Negative 3 plus negative 6 is negative 9. So these are the two numbers you're going to check. So substituting them here, you will replace with them negative 9x. So you are going to say 3x squared minus 3x, which is this one, minus 6x, which is this one, plus 6 is equal to 0. So here the common is what? 3x outside, x minus 1. Here, when you look at these two, we say that if a negative is followed by a positive, factor out the negative of the common or the GCD. So our common is what? Our GCD is 6, so negative 6 outside. This divided by this x less 1 is equal to what? 0. So you're going to say x minus 1, taking one of these two, into 3x minus 6 is equal to what? 0. Then one time, you just come here. One time, we are going to say x minus 1 is equal to 0. So x is equal to 1. The other time, you're going to say or equate this one to 0. 3x minus 6 is equal to 0. So 3x therefore is equal to 6 over 3 cancel. X is equal to 2. One time x is 1 and the other time x is 2. Remember, we have gotten the x values. So let's get the corresponding values for y. We are going to say when x is equal to 1. Then you will come back to this one. Come back to this one because we want to get y values. Remember, we have y is equal to x power 3 minus 9 out of 2x squared plus 6x minus 9. So when x is 1, we are going to substitute the value of the place of x with 1, don't forget. So you're going to say y is equal to 1 cubic minus 9 out of 2 into 1 squared plus 6 into 1 because x is 1 minus 9. So obviously this will give us y is equal to 1. 1 cubic is 1. So 1 squared is 1, yeah? 9 divided by 2 is what? 4.5. Okay, because 1 squared is 1 times 9 out of 2, it will be 9 out of 2. Then it's gonna be plus 6 minus 9. So what you do, add this one, y will be 1 plus 6, 7 minus 13.5. So this will give me negative 6.5. Just understand that. Okay? So in this situation, y, therefore, the point will be, the point is, open the bracket, x1, comma, y is negative 6.5. So that is the first point for your information. Then coming to the second point, okay? Coming to the second point, when x is what? When, let's write that, when x is equal to 2, then y will be 2 cubic minus 9 out of 2 into 2 squared. 9 out of 2 into 2 squared. Just understand that. Plus 6 into 2 minus 9. So this will give us y is equal to 2 cubic, that's how much? 8 minus, this will be 9 out of 2 times 4 plus 12 minus 9 plus 12. So by 2, 1, by 2, 2. So it will be y is equal to 8 minus 18 plus 12 minus 9. So this will be how much? Y is equal to, add 8 plus 12 is change, minus 18 minus 9. So y is equal to 20 minus 18 is 2. 2 minus 9, negative 7. So the other point is, open the bracket, 2 comma negative 7. So these are the stationary points. These are the what? Stationary points. So this is the procedure. What you're going to do is take the equation of the curve, differentiate it. dy over dx. Differentiation we have learned in our previous classes. Make sure you go back and watch those videos. But after getting dy dx, remember at the turning point, dy dx is always 0. Okay? The gradient of the curve is always 0 at the turning point. So at the turning point, comma, dy over dx is equal to 0. That means you're going to equate this value to 0. So it will be 3x squared minus 9x plus 6 is equal to 0. Then solve this one. It's a quadratic equation, remember. Solve it quadratically. You can use the quadratic formula, the method of completing, or as well as you can use sum or what? Sum and product method. For me, I've used sum and product method. Product is a, which is the coefficient of x squared, multiplied by c, which is now in this situation 6. So that will give us 18. Then our sum is always b. Then our b is what? Negative 9. So you'll ask yourself, which two numbers will give me when I multiply them? Positive 18. And when I sum them, negative 9. Obviously, those two numbers are 3 and 6. So the negative, remember again we said that when on the product side we have a positive value and on the sum side we have a negative value. Remember the two numbers we are going to take are both negative. So I will take negative 3 and negative 6. Then replace with it what? The position of what? 9x. So this is form 3 and form 2 concept. Then this will lead you to get the values of x. So if it's quadratic, you will have more than one value. So quadratically I've solved. So one time you're going to say this one in the bracket is equal to what? 0. Another time you're going to say 3x minus 6 is equal to 0. to get the respective values of x for the turning points. Then one time we have gotten x as 1 and the other time as what? As 2. Then we are going to say, remember, you go back to the equation of the curve to get the corresponding value of what? Y, when x is 1. So we say when x is equal to 1, then I'll go back to the equation. Y is equal to x power 3 minus 9 out of 2x squared plus 6x minus 9. Then substituting with the 1. So I have here x cubic, 1 cubic, minus 9 out of 2 into x squared. Our x is 1, remember, squared, plus 6 into 1, which because x value is 1, minus 9. This substitution method, it's also from 3 and from 2 concept. So from there, I got x value as what? Y value, sorry, as negative 6.5. So the point is 1, which is the x value, comma, negative 6.5. Okay? Another time, we are going to take this one. When x is equal to 2, remember we are going to substitute here. So it will be y is equal to 2 cubic minus 9 out of 2 into 2 squared. Remember x is 2 plus 6 into 2 minus 9. Finally, you're going to get what? Y value as negative 7. Now the other point is 2, which is x value, negative 7, which is y value. Then we'll go ahead and see for your information. And we are going to see now, this is how you're going to get the stationary points. Okay, we'll write question B, how to determine the determination of what? Determination of whether this is a maximum point or a minimum point, or what you normally call a point of inflection for your information. Okay, let's see now question 1. Remember, you must have this one in place. Remember, our first point is 1 comma negative 6.5. Then we have also another one as, let's say this is point A and this is point B. Point B is what? 2 comma negative 7. 2 comma negative 7. So we want to determine whether these numbers are what? Whether the turning points here are maximum or minimum for your information. Then now let's see this one. Having those ones, I want to determine them, whether they are positive or whether they are maximum, minimum, or point of inflection for your information. So the second question here is, we are told in each case, this will be a question, in each case, question B here, in each case, test whether the point is maximum, comma, minimum, or a point of inflection, Now, what you're gonna do is, there are 3 ways of testing whether a point is maximum, minimum, or point of inflection. So for me, I will take the simplest way of solving this thing. So remember, I want to test whether this point is maximum, minimum, or point of inflection. It is nothing. You're going to say one time, remember you have x value as 1. Okay? I want to test whether this point is maximum, minimum, or point of inflection. Take the x value, place it here. So tell them, taking a point. Look here, taking a point to the left of x is equal to 1. Remember, when x is 1, this is to the right of x. And to the left of x is this side. Remember, you have learned the number line. So to the left of x is equal to 1 is 0. Okay? So we are going to take what? 0, x. Then what you're going to do is, you will substitute this value in the dy dx. Don't forget that. In dy dx. Remember we said that our dy dx, don't forget, was what? Our dy dx, and like that. Dy over dx was what? It was actually 3x squared, okay? 3x squared minus 9x plus 6. This was our dy dx, don't forget that. Then I will substitute the value of x here. So dy over dx will be 3, look here, dy over dx will be 3 into 0 squared minus 9 into 0 plus 6. So dy over dx will be 6. Again, I'm going to say, look here, I'm going to say what? Don't forget that. I'm going to say, check in. That will not be enough. Okay? So we are going to see what we normally call the gradient change. So check in again, check in a point. That was to the left, to the right. To the right of x is equal to 1. Right of x, left of x is equal to 1 was what? 0. Don't forget that. Then to the right of x is equal to 1, it will be 2. You can take 2. Okay? That will be when x is what? 2. So now come to this point. Come to this point here. Look here. Look here. So I know that my dy over dx is equal to, look at that. Let me write here, because maybe this reflection of light. Dy over dx I know is what? 3x squared minus 9x plus 6. So let me substitute with this value. So I will say dy over dx is equal to 3 into 2 squared minus 9 into 2 plus 6. Okay? Plus what? Plus 6. So dy over dx is equal to 3 into 4 minus 18 plus 6. So this will give me dy over dx, therefore is equal to 12 minus 18 plus 6. So this is 0. Okay? 12 minus 18 plus 6 is 0. So now look here. It is very, very easy. By the way, students are being challenged by this concept. Determination of whether a stationary point is maximum, minimum, or point of inflection. Remember, I will also be giving you more examples. But now just understand. What's happening to dy dx? It's actually reducing. Can't you see now? 6 to 0. So a decrease in dy dx, or the gradient function, shows that the point is maximum. Don't forget that. Don't forget that, please, yeah? Don't forget that. We say that a decrease in b. What's happening? It's decreasing from 6 to 0. So we are saying a decrease in dy over dx shows a maximum point. A maximum point. Therefore, the point which is what? 1 comma negative 6.5 is a maximum. Is a maximum. Very easy. Just understand. You're going to take the x value, then write somewhere. Look here. In each case, you are told test whether the point is maximum, minimum, or point of inversion. Remember, when you take this point, x value is what? One time you're going to say, write this thing. Taking a point to the left of x. Remember, when x is 1, to the left of x is this side. That's for one concept. Elaborate. That will be 0. Take this value 0, substitute in the gradient function. Then get, that will be 6. Take also a number which is to the right of x is equal to 1. That will be 2. Substitute again in the gradient function. So that will give us what? 0. So now ask yourself, what's happening to the gradient function? It's decreasing from 6 to 0. So a decrease in the gradient function, okay, when substituted with the x value of the point, shows that the point is a maximum point. Just understand that. Very easy. And a decrease in the gradient function when the x value of the point is substituted in shows that, okay, an increase of that, an increase in the gradient function shows that the point is minimum. So now let me test also the other point, which is 2, negative 7, and that is the n, of course. That will be the n, of course, okay? Let me test also that point. Let me test that point. Take the point. This is the point. 2, negative 7. So let me say, checking a point. Taking a point to the left of. Taking a point to the left of x is equal to what? 2. When x is 2 now, left of x equal to is what? 1. So remember, dy over dx is equal to what? That was 3x squared minus 9x plus 6. So let me substitute this value into the gradient function. Okay? This will be 3 into 1 squared minus 9 into 1 plus 6. Let's understand the matter of substituting plus 6. Plus 6. So this would be 3 minus 9 plus 6. Okay? That will give us what? 0. It has started with 0, but the initial one was starting with 6, don't forget that. Then, okay, let me check again. Again, let me write the other phrase. I will also say, this was us taking a point. So I will also say, taking a point to the right of x, to the right of x is equal to what? X is equal to 2. So that will be 3 to the right, this side. To the right of x is equal to 2, that will be 3. So I will take 3, yeah? So I will substitute. That is when x is equal to what? Comma, x is equal to 3 when we are saying to the right of x is equal to 2. So substitute, but I know that dy over dx is equal to what? Is equal to 3x squared minus 9x plus 6. So I'll say dy over dx is equal to 3 into 3 squared minus 9 into 3, which is x. 9 into 3, which is x value, plus 6. So dy over dx will be 3 squared, and that's 9 times 3, 27, minus 27, plus 6. So this will give us what? 6. So what's happening to the gradient function? It's increasing. It's increasing from 0 to 6. So an increase in the gradient function shows that the point is what? Is minimum. The point is minimum. So we are going to say an increase in the gradient function shows that an increase in the gradient, in the gradient, not function, in the gradient, shows that the point is minimum. The point is what? Is minimum. Okay? Hence, we are going to say hence, point 2, -7 is minimum. Is a minimum point. Is what? Is a minimum point. Okay? So that's how we are going to solve. It is, by the way, very, 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 very easy, my brothers and sisters. Follow the procedure. Get the stationary points, then test whether. I'm sure it will come in cases in this one. Check it out. For those of 2020 candidates, check it out. This one is very, very much tested, by the way. And it's very easy. Get the stationary points. After that, test each point whether it's maximum, minimum, or point of inflection. In our next class, we're going to see more examples concerning about this before we move ahead and see the application part of differentiation. Otherwise, I wish you the best. Make sure you don't forget to subscribe. Make sure you also say like, increase brothers and sisters like, because it will also boost me. Okay? Help me as well as I also help you. Okay? Otherwise, have a nice day. I wish you the best. Until next session.